Okay, let's look at position, velocity, and acceleration. Right. So let's use the position. I'm going to use h of t for position function. Since I'm going to look at an example of where it represents height. Well, you can use p of t if you want. Then v of t for velocity. And a of t for acceleration, right? And we know the relationship among these three guys. We know that the position function, if you take the derivative of the position function, you will get a velocity function. So if you take the derivative with respect to time, so it's going to be d over dt, you can find the velocity. So velocity is the rate of change of the position with respect to time. And acceleration tells you how fast that the velocity is changing. So this is going to be another derivative to get to the acceleration. So d over dt, right? Then if you want to go backward, we can use the antiderivative. So if you want to go backward, so if you want to go from acceleration to velocity, we can take the antiderivative with respect to t, right? And then if you want to go from velocity to position function, you can take the another antiderivative with respect to t, right? So let's look at a simple example. Right, so here's the situation. So you have a building of height h0, and you have a ball or a rock is shot upward with the initial velocity v0. Right, then we want to come up with the height function of this ball. Right, so let's do that. Alright, start with the acceleration. So ignoring air friction and things like that, we assume that the acceleration is purely from the gravity. So it's a negative g. I put the negative sign because gravity is pushing downward. Alright, then if you want to go to a position function or a height function, we first have to go to a velocity function. Right? So we can get there by taking the antiderivative. So v of t can be found by taking the antiderivative of the acceleration function, in this case just a constant negative g with respect to time. Right? So but this is going to be equal to negative g times t, antiderivative, plus some constant. I'm going to call it the C1. Right? Let's find C1. Right? We know that, so we use this information here. Right? Now we're going to use this information here. So if time equal to 0 in the beginning, so if you plug in 0 here, g times 0 plus C1. So this is going to be just C1. And it has to be equal to V0, right? So V0 turns out to be just a C1 turns out to be V0, right? So we have a complete formula for the velocity, which is negative g times t plus V0, right? Right. Once we got to a velocity function, we can do the same step to go to the position function or height function in this case. So h of t can be found by simply taking the antiderivative of velocity function, which is negative g times t plus v0, right, with respect to time. Right, so antiderivative is going to be negative g is just a constant, so it's a negative g. All right, then antiderivative of t is t squared over 2. Then antiderivative of v0 is going to be simply v0t. Right? Then you might have some constant c2. Right? So let's find c2 using another initial condition. So when t equals 0, initial height is h0. So plug in 0. Right? Luckily, first term is 0. Second term is also 0 times 0. Then so it's again you just have c2. Right? This is supposed to be equal to h0. Right? So therefore, we found a complete formula for the height function h of t is equal to -1/2 g times t squared plus v0t, and we just found that the c2 is h0. Right? So this is the height function, and you probably remember seeing this function somewhere in the physics textbook or somewhere. All right? That's it. I hope that this was clear.